Welcome to the 2011 Enable Training and Consulting FIRST Robotics Competition instructional videos. This year Enable has put together something we call the 7 steps to FRC robotic success. The first step is to start a new FRC LabVIEW project and configure the default code to work for your robot. We're going to go through the default code provided by National Instruments to get a feel for how it works, and then we're going to download that code to a robot controller. After installing LabVIEW, you'll see these 4 icons on the desktop. Go ahead and open the one titled National Instruments LabVIEW 8.6. This will bring you to the LabVIEW Getting Started screen. The Getting Started screen has quick links for starting a new project, as well as links for opening projects that you've worked on previously. On the upper right are links to tutorials for setting up your hardware. These videos assume that you have completed these tutorials and have configured all of your hardware correctly. On the lower right of the Getting Started screen, you'll find technical support links to updates, help files, online discussion forums, and very importantly, FRC-specific LabVIEW examples. Make sure you take the time to explore these links. For our first step, we're going to select the FRC C-RIO robot project in the New category. This will bring up a dialog box for creating a new FRC LabVIEW project. Here you can name the project and place it wherever you want to save it. For the C-RIO IP address, you must replace the XX and YY with your team number. Once you're done, press the Finish button, and LabVIEW will create a project targeted to your compact RIO. When the project has been created, the Project Explorer window will open. This window shows you all the files in your project and lets you open any one of them. We're going to open the robot main VI. Once it's open, press Ctrl-E to bring up the block diagram. This is the main program and is a very high-level representation of the entire project. There are many lower-level subprograms within the project that are contained within the robot main as sub-VIs. This while loop is where all the operational code occurs. This while loop will repeat the code within it until a true Boolean value is sent to the conditional terminal of the loop. First, let's take a look at the begin sub-VI. To view the code contained within the sub-VI, simply double-click on its icon to bring up its front panel, and then press Ctrl-E to open the block diagram and look at the code. This sub-VI is used to initialize all the hardware used by the robot. This program already initializes the camera, the 2 drive motors, and the joystick on the remote controller. Press Ctrl-H to open the Context Help menu and mouse over the icon that says Drive Open to Motor. This function allows you to select which PWM outputs on your digital sidecar are physically connected to your drive motors. The reference opened by this VI is then passed to the WPI Robot Drive Ref Num Registry Set VI. The WPI Robot Drive Ref Num Registry Set VI sets a reference in the registry so that other VIs can get the reference by the ref num name assigned. It's important to remember that whenever you add another piece of hardware to the program, it is up to you to add that hardware to the begin VI. Let's return to the robot main so we can take a look at some other VIs. Take a look inside the main loop. Inside the loop, there is another object called a case structure. A case structure works like an if-then statement in text-based programming languages. The data wire to the selector terminal, which is the little blue question mark, determines which case will be selected and therefore which code will be run. The case structure in the robot main VI decides which code to run based on which mode the robot is in. These modes are autonomous enabled, teleop enabled, autonomous or teleop disabled, timeout, and finally finish. Change the selected case to teleop enabled and double-click the teleop VI to open it. The teleop VI is executed when the robot is enabled in teleop mode. Part of what the code is doing in this case is taking commands from the joystick and transmitting them to the drive motors on the robot. When the program is told to end, the finish sub-VI is executed. Let's take a look at this. Double-click the finish sub-VI and open it up to view the block diagram. This code does pretty much the exact opposite of the begin sub-VI. As part of maintaining good code structure, every reference that was opened in the begin VI should be closed in the finish VI. To close the reference to the motors, use the ref num assigned when the reference was opened. Now return to robot main. This program is ready to be deployed to the robot. To do this, make sure you have communication with your robot and click the Run button on Robot Main. The code is then compiled and downloaded to the compact Rio. Once that is done, the robot is ready to run. Before you can send commands to it, you must open the FRC driver station. The driver station has 3 LEDs indicating the status of communication, robot code, and the stop button. When all of these LEDs are green, then your robot is ready to run. Make sure you lift your drive wheels off the ground before you run the code for the first time. Click the teleoperated button to select teleop mode, and then click the Enable button. Your robot should now send your joystick commands to the drive motors. In step 1 of our 7 steps to FRC robot success, we looked at how to configure the default FRC LabVIEW code to work for our own team's robot. We took a look at the key components of the FRC C-Rio project, and finally we compiled and downloaded the code to the compact Rio controller.